All right, have your homework out if you would, please. And I want to start by looking at the second thing that I gave you. I gave you 2 points. M was the point 47, and then J was the point -2, -1. And I wanted you to find the length of MJ, the midpoint of MJ, the slope of MJ, and the angle of inclination of MJ. And what's the distance formula that we use to calculate length? Jamie?
The square root of the change in x squared plus the change in y squared.
Good. And so when you found the change in x, that was
6
squared.
36.
And when you found the change in y, that was
8
squared.
64.
So the length was
10
units, the square root of 100 or 10 units. Then for the midpoint, what's that formula, Quentin?
x1 plus x2 over 2 and y1 plus y2 over 2.
And I think I actually asked you both those same ones. I should have mixed it up because in the last lesson, I think I asked you that one or that one. Anyway, all right, poor planning on my part. And so when you add the x's, you get 2, cut it in half, you get 1. When you add the y's, you get cut it in half, 3. And there's our midpoint of MJ. To find the slope of MJ, what's that equation back to Quentin? The formula for slope.
The change of
It's rise over
it's
run.
y2 minus y1 over x2 minus x1.
Good, let's say that formula together, class. y2 minus y1 over x2 minus x1. And so remember the y values, we could plug them in either order, but the order matters. So it's not just going to be, okay, what's the change? We actually have to be careful with the order here. Quentin, how did you set up the numerator?
7 minus -2.
Oh, careful.
Or
Put a y with another y. Don't put a y with an x.
7 minus -1.
7 minus -1. Okay, Jamie, since he started with the 7 in the numerator, what x value do you have to start with in the denominator?
4
4 minus...
-2.
In both cases, they're minus negatives, so in both cases, they just become positives, and we end up with 8 over 6. However, slope is a fraction, and all fractions have to be reduced, so we shouldn't leave 8/6. We should say
4/3.
4/3. Do we remember to reduce, think to reduce? She's saying yes. You had the wrong thing anyway, because you put the -2, didn't you? All right, so does it make sense to always reduce your slopes? And then for the angle of inclination, obviously the slantiness of a line would be the slope, but you could also say the slantiness determines the angle of the line as well. Remember, the angle of inclination is the angle made with the... Well, I'm not asking for the formula, but the angle of inclination of a line. For instance, we said the slope here is 4, 3. So we would, from any point, just pick a random point, rise 4, run 3. This line slants like this. Where's the angle of inclination for that line?
It's with the x-axis.
The positive x-axis, or the right side of the x-axis. So here's my angle of inclination, and how do I find, this is what you were trying to answer a minute ago, how do I find angle of inclination, Jamie?
The arctangent slope.
The arctangent of the slope. So we'll take the arctangent of 4/3, and we end up getting what angle of inclination, Quentin?
53.1.
Good, if we rounded just the 1 decimal place, 53.1 degrees. Is this what we had on the homework? Other than, well, actually no, because your angle would have been different initially because you had a different slope initially. All right, but you kind of redeemed it there. I noticed you plugging it in. All right, questions on this? All right, we're going to work more with slope and angle of inclination in this lesson. But for now, let's go back and hit the other part of the homework, which was page 204, number 12. I think it was letter C. Is that right? So back to page 204, number 12, letter C. Again, we're finding the length of a chord formed by the intersections of 2 equations. So letter C, we had this equation, y equals x squared minus 1, class that is a parabola. And we had a 4x minus y equals 4, that is a straight line. We understand that the straight line and the parabola realistically could intersect twice. We're finding the length of this chord of the parabola. Again, chord is a term we used in geometry for circle, but really any 2 points connected on a curve, which a parabola is, would be a chord. How did you go about solving this system to find, first of all, the points? Because you can't find the length until you find those points. How did you find the points? Jamie?
I substitute the y in the second equation with the x squared minus 1.
All right, good. That's what I would do as well. It was already set up for us. However, we do need to be careful because of this negative. So how do I write it, Jamie?
It's gonna become the negative x squared plus 1.
Good. 4x negative x squared positive 1 is equal to 4. And Quentin, from there, what should we do?
I move the x squared to the front, change all the signs.
You move the x squared over to the right?
No, to the front.
To the front, okay. Now it is a negative x squared. I really don't like that negative right there. So that was why I thought when you said move it, my brain filled in, you move it over there. I was like, wait, I don't think that's what I heard. So we could put the negative x squared first and then the positive 4x. For that matter, we could also bring the
4
to get,
negative.
but because of the leading negative, what should I do next then?
Change signs.
Change all the signs. And nothing wrong with doing it this way at all. My preference would have been put the 0 here, kick everything else out there to get 0 equals this, save one step, but nothing wrong with this method at all. All right, from here, Jamie, back to you.
Backwards pull and get the x negative 1, x negative 1.
There we go. And we'll set each factor equal to 0 to get two x values, two abscissas for my, because 2 points of intersection. Those are, class? 1 and 3. We need to go back now and get the y and preferably plug into the lower power equation, which would be this one. Not wrong to plug it in here. Technically, we'd want to plug it in here, but we've got the negative y. I'm thinking maybe a double switch here. We said 4x minus 4 equals y. That'll make it a little easier to plug in the 1 class and get 0, though you'd get the same thing here. And then plug the 3 in here and get, though again, technically you would get the same thing here. There are some instances in which if you plug into the higher power equation, it can actually produce extra answers. That's not going to be the case here. So my points are 1, 0, and 3, 8. This is clearly not drawn to scale. We needed to find the length of the line. Now, pause. Did we get these 2 points in the homework? Jamie's saying yes. Okay, did you figure out where things went south? Was it right here with the negative?
No, I did the, I plugged in the negative, but when I changed the signs, I forgot to change the 4 on where it's negative.
Oh, so you had plus 1, plus 3. So you had negative 1, negative 3.
Well, I had negative 1, 5.
Right, negative 1, 5. Negative 1 and 5 for these numbers. So somehow you got a 5 instead of a 3 right here as well. So a couple mistakes then that got us there. Okay, all right, so let's come to Quentin then and have you finish this out for us. If 3, 8, 1, 0 are my points, how do I find the length of the chord?
It's square root of the change in x plus change in y. Well,
Close.
squared.
Squared, there we go. Change in x squared plus change in y squared. So the change in x is
2,
squared,
4,
and the change in y
8,
squared.
64,
And we add it together, we get the square root of.
68.
However, you can reduce it. It's sneaky, but how did you factor the 68, anyone?
4 times 17.
4 and 17. So the correct answer is
2.
2 times the square root of 17 units. All right, is that what you have for your answer? Great job, Jamie. And then just some little things here, but we understand it now. All right, any questions at all on this part of the homework? Any questions? All right. Well, let's go ahead then and turn over to page 208 in your textbooks. Let's get back to slope and angle of inclination. Page 208 and number 4. Go ahead and read the instructions there on the very first problem at the top of the page, if you would, Quentin.
Find the slope of each side and the median on each side of triangle ABC.
All right, so kind of like we did in the previous section, let's start by drawing a nice big triangle. Give ourselves plenty of room to work here and label it ABC. We'll put the coordinates there. A was 1, 0 on number 1, letter A. Letter B, angle, vertex B is at negative 3, 4. Vertex C at negative 1, negative 3. And it doesn't want the slope, or it doesn't want the length of each side, it wants the slope of each side. So let's go and find the slope, little m, remember, sub AB. And what do we get for the slope of AB? Call it when you've got it.
135.
Okay, not the angle of inclination yet, just the slope. What's the slope?
Oh, -1.
-1. That's all we were looking for. We could do angles of inclination here in a minute, I suppose, but -1's the slope. Good to go?
Mm-hmm.
All right, find the slope of BC. And call it when you've got it.
-2.
I take the time to write the numbers in. Maybe not write y2 minus y1 over x2 minus x1, but think y2 minus y1 over x2 minus x1 as you plug in some numbers.
-7 over 2.
Yeah, -7 halves. Or -7 over 2 is what we should have. So I did 4 minus -3 is 7. -3 minus -1 is -2, so 7 over -2. All right, find the slope of AC, and we'll have Quentin call it when he has it.
-3 halves.
We're going to have +3 halves. So let's see, we got 0 minus -3 over 1 minus -1. I get a +3 halves. All right. All right, next thing it wanted, it said find the slope of each side and the slope of the... Find the slope of each side and the median. Okay, now that's not the no-name line. If it was the no-name line, it'd be -1, -7 halves, 3 halves, right? Because they're all going to be parallel to their opposite side. But median, remember, in a triangle goes from vertex to midpoint. So remember, there's a median that goes from this vertex here to this midpoint here. Well, what are the coordinates of that midpoint going to be? Remember, now you're adding and dividing by 2. Add and divide by 2. -1, 2. So now we want to find the slope of this median that goes from -1, -3 to -1, 2. Call it when you've got it. It is undefined, isn't it? You end up with either 5 or -5 over 0, don't you? Let's quickly refresh our memory. Undefined lines, undefined slopes look like what? Straight up and down line, a vertical line. So apparently this median is actually straight up and down, vertical. Now this slope and this slope, they're both negative. What does negative slope look like? Yeah, it looks like it's going downward this way, right? Technically it's rise and run backwards, but it looks like it's going down. This slope is positive. Positive slopes look like they're going upward here. And then the other kind of slope would be a perfectly horizontal line. Because it's not going up, it's not going down, it's not vertical. Horizontal, what would be horizontal slope? 0. That would be 0 slope if we saw something like that there. All right, let's do this with another median here, and let's go from A to this midpoint here. Go and find that midpoint of side BC, if you would please. Yeah. -2, 1/2. All right, here we go. Let's go and find the slope here. And again, fractions can be a little bit obnoxious, so let's refresh our memory how to work with them. We're still going to say that the slope is equal to the change in y over change in x. Well, I can either say 0 minus 1/2 or 1/2 minus 0. 0 minus 1/2, all right. And then if I'm going to say 0 minus the half, I have to say 1 minus the -2, which is going to give me in my numerator -1/2, and in the denominator,
3.
a +3. Well, remember, this fraction bar means what? Divide. Do I ever really divide though when there's fractions involved? I always multiply by the reciprocal. So I'm going to change this to say negative a half times the reciprocal of 3, 1 over 3. So what is the slope of this median here? Negative 1/6. All right, we have one more median. And by the way, remember, all of these medians will intersect perfectly at the true center of gravity, center of mass, called the centroid. Do you remember that term from last year? Okay, those will all intersect at the centroid. But let's go ahead and find this midpoint now, the midpoint of AC. The midpoint of AC.
0, -2.
-1.5. Or we'll say negative 3/2. All right? So find at your seats the slope of the line. Just be careful with your fractions. Actually, let's do this one together. All right? So remember here, we're going to put our y2 minus y1. I'm inclined to say 4 minus negative 3/2 and negative 3 minus 0. But right here, this is annoying, isn't it? Right? Instead of 4, how could I rewrite it so it had a denominator of 2? 8/2. It's easier if you make things fractions in your operation, plus the minus negative becomes a plus. All right? So 8/2 plus 3/2, 11/2, and then here we just get negative 3. If I wanted to, I could say negative 3 over 1. The only advantage, I suppose, in that is that when I see the division in this complex fraction, I know I need to multiply by the reciprocal. So I'm going to change this to 11/2 times negative 1/3. What is the slope of this yellow median? Negative 11/6. And there are my 3 slopes of the sides and my 3 slopes of the medians. Questions on letter A? Start letter D. I'm going to start working in it, but I want to give you a head start on it. See if you can do letter D. And you're going to want more room than that. There you go, Jamie. It's like, you're not going to try to squeeze that in, are you? No.
We're doing D?
Letter D. Yes, number 4, letter D. Compression that you get there. So you find that one and use that number for the G, and then find that and use that number for the F. Do this on the graph paper here at the bottom. Good practice with slope formula and midpoint formula. I haven't used the midpoint as much as we've used distance, so we're going to give that a workout here. Number 4, letter D. Alright, once you've got all three slopes of the sides and all three midpoints, check your answers on slopes and midpoints before you do slopes of medians. No sense doing slopes of medians if the midpoint's off. Find all three, check all three midpoints, check all three slopes. Questions, of course, if you have them, please ask. Alright, looks like Quentin's fixing something. What was it?
The median of AB.
Median, or the midpoint of AB?
Oh, yeah.
Alright. Did you get everything else right of those 6 things?
No, I missed the, I think that's what I did. I found the difference of the X and Y's.
Instead of the, well, technically you do, right? That's what it is. It's change in X over, or change in Y over change in X, right? So 5 minus negative 3 over negative 5 minus negative 2. And that's where I got the 8 over negative 3. What did you have for your slope?
2/3.
Okay, so here you added them instead of subtracting them. That's where you got your 2. And then here you really did subtract them. That's where you got the 3. So just be careful. Again, it would be good to show this. It'd be really good to show that. On a quiz or test, I still would, like when I'm doing answer keys. I make sure I show that so I don't mess it up. Here, you know, I figure if I mess up, y'all catch it and fact check me. Now, Jamie, have you checked your slopes and midpoints yet? Everything's good to go? All right. Once everything's good to go, find the slopes of your medians. Color coded here for you since I didn't want to squeeze everything inside the triangle. So here we have this white median slope, blue median slope, and the yellow median slopes. Jamie's checking answers.
The other thing, the 6/13, I forgot to cancel both of the negatives, so I had negative 7/13.
Right here?
Oh no, at the end, like I had negative.
Oh, you had negative over negative, so negative 6 over negative 13. Okay.
That's the only thing I did.
All right, Quentin. once you fixed midpoints, all of that.
That's what it is.
All right, any questions at all on that? Now, one thing I want to bring up here with you, and I'm going to erase some of this extra stuff here, but I want to lock in just on these two slopes right here. Side AC has a slope of -8/3. Side AB has a slope of 7/5, correct? That means this line has a particular angle of inclination. This line also has a particular angle of inclination. How do we find angle of inclination? Arctangent of the slope. So let's find what is the angle of inclination for side AB.
$54.5.
54.5 degrees. All right, what about AC's angle of inclination?
-69.4.
Initially -69.4, but remember the angle of inclination always falls between what two values? 0 and 180, right? 0 degree angle for slope of 0. Slope 0, angle 0. All of your acute angles are your positive slopes. Your 90 degree angle is your undefined slope, and then all of your negative slopes are obtuse, angles up to 180. So the arctangent's going to give you a negative value for anything that's negative slope. What do you have to do to compensate? Add 180 to get what angle? 111 point...
110.5.
110.5? Okay, let's go with 110.5 degrees. Now we can use these two angles to find the measure of angle A. It's often helpful if we draw kind of a quick sketch of what we're looking at here. So, for instance, A is -2, -3. A is going to be down here-ish. B is going to be up here somewhere-ish. And C at -5, 5 is going to be up here somewhere-ish. This line, and this line. All right? Now, technically, zoom in just a little bit over here now. This angle right here, this is the 110.5. Does that make sense? This angle right here is the 54.5. But if we were to draw a little extra axis right here, a parallel to the x-axis, you realize this is still going to be 54.5, correct? And this is still going to be 110.5, correct? How big then is the actual angle A going to be?
56.
Good, it's going to come out to almost exactly 56 degrees. You see how you can find angles of a polygon using angles of inclination. Find for me the angle of inclination of BC, given its slope of -1/8. Good, it's going to come out to 172.9 after you add the 180, correct? Now what that means is, now notice this line BC never actually crosses the x-axis, does it? But if I drew kind of a parallel to the x-axis, this angle is the 172.9 right here, correct? And if I were to draw that here, a parallel up through C, this angle here would be the alternate interior, wouldn't it? It's 172.9 degrees. But this angle is alternate interior to the 110.5. So how big is the real angle C?
62.4.
It ends up being 62.4-ish degrees. Does that make sense? You see how you can use angles of inclination to actually calculate angles of a polygon using slopes. That's what we're going to work on more tomorrow. However, I'm going to give you a chance to try one of those in your homework this evening. You'll do just one of these in your homework this evening. For homework, I want you to give yourself 3 points, A, B, and C. I'm going to go and write them on the chalkboard for you. Make it a little easier to copy down. 3 points, A, B, and C. And these are the 3 vertices of a triangle on the Cartesian plane. A has the coordinates 3, 7. B has the coordinates 1, negative 3. And C has the coordinates negative 6, 5. I want you to find the length of each side. I should have erased all the way. So I get for trying to be lazy. The length of each side. I want you to find the midpoint of each side. I want you to find the slope of each side. I also want you to find the length of the median from C to the midpoint of AB. Just realized I think I moved the camera to the other end of the chalkboard earlier. Let's move it back here. And then finally, I want you to find, see if you can do it, angle B. All right, that's what we're going to focus on more tomorrow, is finding those angles. But I'm curious to see if you can figure out angle B on your own with a couple of things that I showed you. The rest of this should be really straightforward, though. All right, we'll take a look at that in our lesson tomorrow. Have a wonderful rest of your day. And when the bell rings, you'll be dismissed.